students are very much happy to invite you for another topic here. So we know what is a matching there. As look at the picture there, V1, V2, V3, V4, V5, V6. This is a graph, of course, consists of vertices and edges. Now what is a matching? Matching, I told you already. Matching means what? The edges which are not adjacent to one another. That means they are independent of one another. Okay, take for example V1, V2 is independent of V3, V4 because there is no common vertex for that. Therefore, they are not adjacent. Similarly, V3, V4 is not adjacent to V5, V6. So V3, V4, the edge, V3, V4, the edge is independent of this, and this is independent of this. Similarly, this edge is independent of this edge. This edge is independent of this edge, and this edge is independent of this edge. Okay, because there is no common vertices for them, they are independent of one another. Such matching we say, such independent edges we say matching. So here I am giving you, this is one matching, this is second matching, and this is third matching, like that. Now next concept here is about symmetric difference. M1 delta M2, M1 delta M2, symmetric difference we say. What is the symmetric difference? Means the cycle between M1 and M2. You take M1 here, M1 is V1, V2, okay, V1, then you are taking V2, then V3, V4, V5, V6, again V3 it goes. You must understand that it start from a non-independent vertex and make a cycle from that. V3, V4, V5, V5, V6, V3. Okay. So V3, V4, V5, V6, again V3. We can make a cycle that. Such a cycle is called a symmetric difference of this matching and this matching. Okay. Now coming to the M3 augmented path. What is an augmented path? First of all, augmented path is nothing but an alternative of the independent edges and non-independent edges. Okay, that's called what? Augmented path. Here V3, V4, V5, V6, V5, V6, V3, V4, V3, V4, and then you are taking one non-independent edges comes, then we get the independent set here. Okay, so now V2 here, V3, this is what free vertex we say is starting here, non-independent. Okay, then non-independent, we can say that dependent, then independent, dependent, independent, and dependent, like that it comes. Okay. So augmented path is one which is alternative of independent, dependent, independent, dependent. I mean independent edges, and which is not coming in this set, but this is coming in the graph edge set. Okay. So the alternative path of like this, we call it as augmented path. Augmented path. This is what we call augmented path. So an alternative path is called an augmented path. Augmented path. An alternative path, we call it as augmented path. Okay. So like this we can explain. Next one is a very important theorem there, and before that I do want to give you a simple example about the augmented path and the alternating path. Alternating path and the augmented path. Consider M. What is M? Set of independent edges, which is contained in the set of edges of G. Then any vertex is called a free vertex if it is not an end point of any element of M. End point of any element of M should not be there. Coming to this particular picture, this is the end point, this end point, but it's not end point of M here. This end point of M, this end point of M, this end point of M, this is end point of M. So this and this are end point of M. So any vertex which is not end point of M is called a free vertex. Now an alternative path is a simple path in G whose edges alternatively belong to M and to E minus M. Subtraction of this set E, subtraction of the graph vertex, graph edges from subtraction of this M independent edges from the graph edges. Okay, that alternative path we call it as alternating path. See here, from here to here, this is not belonging to M. Okay, so this not belongs to M, but this belongs to M. This not belongs to M. This belongs to M. This not belongs to M. Understand that? So this type of a path we call it as alternating path. A path which consists of non-independent edge and the independent edge. Not independent edge, independent edge, not independent edge. This path we call it as alternating path in any graph. Now look at this, an augmenting path with respect to M, alternating path between two free vertices. Alternating path between any two vertices, free vertices, very important, is called an augmenting path. Look at this. This is one free vertex. These are a free vertex. So these two are free vertices. There exists an alternative path or alternating path, and therefore this particular path we call it as augmenting path. What we say? Augmenting path we say. Okay, so augmenting path, that's what we are looking at that into fact. Okay, now so in the next slide we are going to see the slides that for that no time. In the next class we will look at a theorem, very important theorem in this augment based on the augmented path. Thank you.